Hello everyone, here is your teacher Neha, and in this video I am going to discuss more about ligands. In my previous videos related to this chapter, I have described about coordination compounds, their properties and how they are different from double salts. The link of which I am giving in the description box. You can check it out there. And today I am going to explain the ligands and how many types of ligands are there, and how the different ligands bind to the metal atom, how differently they do. I will discuss all these things in this video. So before starting, please subscribe, share and do press the bell icon so that you get the necessary notification about the new videos I am posting in this channel. So let us start the ligands. Ligands are the atoms, molecules or ions which donate a pair of electrons to the metal atom or ion to form a coordinate bond. That is, they are having lone pair of electrons. This is the must thing. The first thing that is necessary to become a ligand is the lone pair of electron. Okay, so these lone pair of electron, they are going to donate to the metal atom, to the vacant orbital of the metal atom. The metal atom may be neutral metal atom having vacant d orbital, or it can be an ion. Okay, so the lone pair are donated to metal atom, and since the pair of electrons are donated to metal atom, the coordination bond is formed between metal and the ligand. Ligands donate the lone pair, that means they are acting as a Lewis basis. So all ligands are Lewis bases, whereas the atom, central metal atom, which is accepting the lone pair of electrons, are acting as a Lewis acid. Now the ligands can be very simple molecules like chloride, very simple ion, simple species like chloride ion. They may be neutral molecules like water molecule or ammonia molecule also. Okay, these are very simple molecules, are having lone pair of electrons, so they can act as ligand. Now the bigger molecules or macromolecules like ethylene diamine having 2 NH2 group attached to ethane molecule. Okay, so this is a ethylene diamine. It has the nitrogen which is having a lone pair of electron, and it can work as ligand. We are writing En for the ethylene diamine as a ligand. Some macromolecules or bulky molecules like proteins also can act as ligand. Okay, now the ligand may have one donor atom to donate a pair of electron, or may it have more than one atom to donate a pair of electron. So the number of coordinating or ligating groups present in the ligand is known as denticity. Denticity is what? It is the number of coordinating groups. Here nitrogen is coordinating group, 2 nitrogen is there. Here 1 oxygen is there. Here 1 Cl is there. Here 1 nitrogen is there. So it is known as denticity. The number of coordinating groups present in the ligand is denticity. So according to denticity, the ligands can be classified into various categories. For example, monodentate, bidentate, terdentate or tetradentate. So let us see what are the types of ligands possible. Okay, the ligands, the first type is the monodentate or unidentate. It's unidentate ligands. Okay, the examples of which can be water molecule, ammonia molecules as neutral molecules, and chloride ion, bromide ion, OH minus ion, they all can donate only one lone pair from one atom only. So they are so they come under the unidentate ligands. The second is the bidentate or didentate ligands. These ligands have 2 coordinating atoms within the same molecule. So they can donate their lone pair, both the lone pair from different atoms to the central metal atom. This type of when donation of electrons are present there, they are forming a closed structure. Okay, they are forming a closed structure which is known as chelate ring. It is known as chelate ring. And the ligands which are forming this type of closed structure, they are known as chelating ligands. Okay, and this whole structure, the metal ligand structure, the whole spatial arrangement is known as metal chelate. Right. There is one more example I can give you as a bidentate ligand is the oxalate ion. Oxalate ion, CO minus here. These two oxygen atom, they are having lone pair of electron and can donate to the metal atom and also can form a chelate. Right. The next example is of tridentate or terdentate ligand. Terdentate ligands have the three coordinating sites within a one molecule. Here you can see the structure of diethylene diamine. Here the three nitrogen atoms are present which are having lone pair of electron, and they can coordinate with the metal ion from the three sides, and thus there is a chelate formation here also. Okay. Next is the terdentate ligand. So the next example is of tetradentate ligand, also written as example is triethylene diamine. Here the three ethylene diamine molecules are added together to form a big molecule. Okay, so here you can see there are this is 1, this is 2, this is 3 ethylene diamine molecule, and they are having the 4 nitrogen atoms having lone pair, so they can coordinate with this nitrogen atom there and there. So a 3-ring chelate is formed by this molecule. So they are all chelating ligands, right? The hexadentate ligands are also possible. Hexadentate, the best example is the EDTA. So this is the structure of EDTA. EDTA means shorthand it is written as EDTA, means ethylene diamine tetraacetate ion. You can see there, here is ethylene diamine. Diamine, it should be NH2NH2, where the 4H of this nitrogen, 2H of this and 2H of this nitrogen atoms are replaced by acetate ion. So it is a tetraacetate ion. Ethylene diamine tetraacetate ion. It is a hexadentate ligand. Okay, it is the hexadentate ligand. It can coordinate with a metal atom with its 6 sides, 4 acetate oxygen from the oxygen and 2 nitrogen having the lone pair. So it is the hexadentate ligand. Now, greater is the denticity of the ligand, more stable is the complex form. That means the chelate, when there is a chelate formation in a coordination compound, the complex is more stable, and the chelating ligands form the more stable complexes than the unidentate analogues, and this is known as chelating effect. This is known as what? Chelating effect. Okay, this is known as chelating effect. Now, the ligands with large groups. This is the large group and forming chelate. If there is a ligand which is small and forming a chelate, so the smaller groups forming chelate rings are more stable than the bulky groups that are forming chelate, and this can be understood from the steric hinges. Okay, you can visualize this thing, because the big groups, bulky groups, can cause the steric hindrance and the steric effect. So the steric effect, due to steric effect, they are less stable. Smaller groups with chelate ring is more stable, right? So these are the types of ligands on the basis of their denticity. Now, one more type of ligand, you can say that the ligand in a same ligand which is unidentate, having one atom for coordinating only, but there is more than one lone pair of electron present in 2 different atoms within the same molecule. Okay, this type of ligands are known as ambidentate ligands.